Okay, we should be looking at our Unit 2 transformations. This is day 2. We're going to focus on specifically rotations and dilations. So, zoom that back out a little bit. Rotations. A rotation is just called a turn. Get a pen. It's a turn around a fixed point called the center of rotation. Okay, this is the fixed point in this. Most all the time when we're going to do them, we're going to rotate around the origin 0, 0. Like you can see these pictures here kind of spinning around that middle. A figure rotates a specific angle, like 90 degrees, 180, whatever, and a specific direction. Whether it's going to spin clockwise or counterclockwise, so it will be important to read that part. Now the formulas I'm going to list here, these are rules for rotating counterclockwise. Counterclockwise about the origin, meaning all these we're going to do are from the origin at 0, 0. So if you look at this arrow is going this direction. That direction would be counterclockwise. You'll notice they still put the little apostrophe by these to show that those are the new image and this is the pre-image. So if you were going to rotate that direction, what would happen to your x and y values? So your x and y, this is called a symbolic rule. It has to change if it's going to move to a different location. So what you're going to do is you're going to take the y value and you do the opposite of the y. So you write negative y and then comma x. So the x and y kind of flip-flop positions here. And you'll take the y value and it becomes negative, because if you look over here, these would be negative x values, so that's why that has to be a negative number, or the opposite of whatever it happens to be. Okay? We'll do these with numbers, it'll make more sense. The rule for 180 degrees, now if you think about 180 degrees, that's like 2 turns, whether you go counterclockwise or clockwise. This one doesn't matter because you'd end up in the same quadrant. But if you were going to do 2 turns of a triangle, and it comes down here, this would be the formula opposite of x, comma, opposite of y. So they're going to stay in the same order. You're just going to make each of the numbers become opposite of whatever they are. So just a little note, when you see this sign, think opposite. If it's positive, it becomes negative. If it's negative, it becomes positive. 270 degrees counterclockwise, that's the essence of going 3 turns. 1, 2, 3 to get to that. Because 360 would be all the way around. The rule for going, let's kind of put arrows, going around that way, 270 degrees is y, comma, opposite of the x. So you're not only going to flip them, but now the x is going to become the opposite of whatever that number is. Let's try this with some pictures. To save some time video-wise, because I think you guys can probably all graph these, I went ahead and just highlighted the x and y axis here. Just so it stood out a little bit better on my pictures, I went ahead and graphed the original ABC or XYZ. So if you want to pause the video, go ahead and pause the video, graph all the original pictures, and then go back and turn the video back on to figure out how to do them. So this one says 90 degrees counterclockwise. So the rule for counterclockwise, up at the top for 90 degrees, is opposite of y, comma, x. So we're going to look at the point A. Point A is the point 2, 7. Okay? This is your x. This is your y. So if we want to take the y value now and write it first and write the opposite of it, the opposite of 7 would become negative 7. And then the x value goes next. So you're just taking these 2 numbers for x and y and basically plugging it into that formula, and that's your new ordered pair. So let's graph that point, negative 7, 2. So here is the new value of A, so I'll put a little exclamation point, or I mean not exclamation, a little apostrophe next to that so you can see that. Doing the same idea for B. Your B value is at 6, 5. If you put the y value in the formula here, the opposite of 5 would be negative 5. And then the x value goes in that spot. So this would be 6. So negative 5 would be right there. Negative 5, 6. A new b value. Going to do the same thing for the c value. 4, 1. So according to the formula, you put the y value here, so that will become negative 1, 4. Hopefully this is looking right. So basically, if I took this one I have in black, and I rotated it 90 degrees counterclockwise, we know it should be in this quadrant, right? Because that would be one turn, or one quadrant it's going to move, and it's spinning around this point. So the A should now spin to go down here, the B will go up top, the C. So this formula, these formulas are going to be important to memorize for this test. Let's try the next one. Next one says 180 degrees. It doesn't say counterclockwise or clockwise because either way you go, it's the same. So 180 degrees, the formula for this one is the opposite of x, comma, opposite of y. Opposite of x, opposite of y. So if our x value is 3, the new x value should be negative 3. Opposite of negative 2 would be positive 2. That's your x. Do the same thing with your y. Opposite of 6, opposite of 1. Becomes negative 6, negative 1. Okay, the last one, opposite of 5 would be negative 5. Opposite of negative 7 would be positive 7. Okay, these, I'm going to put the little exclamation point by these because these are my new image. After the pre-image, again, this would be taking this picture, rotating it 2 turns to be 180 degrees. Okay, let's look at the next one. This time it says 270 degrees counterclockwise. I'm going to go back up and make a little note here. Where we have 270 degrees counterclockwise, that we're going to say is the same as 90 degrees clockwise. So if you go 3 turns to the counterclockwise, that would be the same as going 90 degrees clockwise. Okay? Alright. 270 counterclockwise. The formula is y, comma, opposite of x. Okay? So the y value for C is 5, and the opposite of negative 5 is positive 5. Okay? On D, the y value for D, remember this is x, this is y. So the y value is 7. The opposite of negative 1 would be 1. E value. So 3 is our y, so I'll put that first. The opposite of negative 3 is positive 3. And the last one, 1 is the y value, and the opposite of negative 7 is 7. So if you spin this 270 degrees counterclockwise, that's 90. There's 180. That would be 270 because it goes 3 turns. Those would be its new picture. Okay, that's everything on rotation. Important to look back over these know these rotation formulas, basically. Rotation rules is what they call them. Let's move on to dilation. So far, everything we've done in our problems have all been exactly the same size. We've done translations, where it's a slide. You've done what's the other one we've done? We've done rotations. That doesn't change the size. The only thing that we're going to do that changes the size of something is called a dilation. You think about when you go to the eye doctor, they dilate your eyes, they make your pupils bigger so they can see and look at your eye better. So a dilation is going to be an enlargement or a reduction. A dilation getting bigger would be an enlargement. If you dilate something half the size, that would be getting smaller. So you can dilate something to a fraction of the size. The scale factor indicates how much the figure will enlarge or reduce. Okay? Variable for scale factor is the letter K. K stands for scale factor. If the K value, if the scale factor is greater than 1, then the dilation is an enlargement. If you have a scale factor of less than 1, it means it's getting smaller, so it would be a reduction. Alright, so we're going to look at the scale factor. A scale factor, as long as it just gives you a scale factor, we're dilating the whole picture by this. Whereas later on this chapter, we might get into just dilating the x values or dilating the y values. So it might stretch a picture one way or the other. Like, you know how like in a document you can drag one corner of a picture and it kind of stretches it. Today's dilations, we're dilating the entire picture, not just part of the picture. So this one has a scale factor of 2, which means we're going to take every ordered pair you see and just multiply it times 2. So let's take our first ordered pair we have. We have the ordered pair R is -5, 1. You're going to take each individual of those numbers and just times it by 2. So times 2 times 2. So your new R value would be -10, 2. That's it. You just times every number in the column times the scale factor. Again, you can see, like I said at the beginning, pause the video, draw all the original pictures so that you have something to compare it to. Right? You take the S values times 2, you get -6 and 8. T values would be 4 and -2. So the idea is this new picture, with my little apostrophes, this is twice as big of a triangle as the original. The next one you'll notice has a scale factor of 1/3. So if you were to take, say, -15, right, times 1/3, because we're multiplying by the scale factor, that is the same thing as doing -15 divided by 3. So anytime you're multiplying by a fraction, if it's 1 over something, you can just do, basically divide, like taking times 1/2, that's the same as dividing by 2. So taking times 1/3, that's the same as dividing the number by 3. Times 1/4 would be dividing by 4. The only thing weird is if you have a scale factor that's like a scale factor of 2/3. Then you might want to actually, you would multiply this and then divide by. In this case, since they're all 1/3, we can just divide each of these by 3. -3 divided by 3 is -1. -12 divided by 3 is -4. -5. 0 divided by 3 is still 0. So those should be our new ordered pairs. I'm labeling my new picture. I didn't do that very good, but so this triangle should be 1/3 the size of the old triangle, or the original image. Alright, now they've drawn two pictures for you. Remember how you identify the new image versus the original or a pre-image is they have the little apostrophe by the new image. So this picture here has the apostrophe by them, so that's considered the new image. So the scale factor should be getting small. It should be a fraction because it's a fraction of the size. So what you do is you write down the original point, just pick a point. Let's say D has the point 0, 6. The new D is at the point 0, 2. So when you want to try and figure out what the scale factor would be, I always try and write it as the new image, or new versus the original. And this fraction would be true for any point you picked. I just picked D. You could pick E, you could pick F, any point you want. So the new image, well, 0 over 0, that's not really going to tell me much, but this would be, new image has a point of 2 for the Y and 6 for the original. So 2 over 6 would reduce to 1/3. That picture should be 1/3 the size. Okay, I'm going to do the same thing now. This one, though, these have the apostrophe. So this one here is getting so many times bigger than the little one. So let's just pick a point. Let's use X. X is at 2, 0. The new X is at 8, 0. So new image, new versus original. That would be 8 over 2. It's 4. So that new picture, the one with apostrophes, is 4 times as big as the original.